Today's lesson, 7.7, Practice with Rational Bases. Our goals for today. I can change an expression with a negative exponent into an equivalent expression with a positive exponent. Our second learning target. I can choose an appropriate exponent rules to rewrite an expression to have a single exponent. As we work through our slide presentation, please open up your book to page 38. If you don't have your book, it's okay, you can still follow along. So page 38 in your illustrative math workbook. Let's remember our 5 rules. Let's do a short refresher. 5 rules that we've learned so far. First rule, when we're multiplying with exponents, we're going to add our exponents when we have the same base. So that's going to look like we're going to add our 2 exponents, n plus m. So this is how it would look like with numbers. If we had a base of 4, an exponent of 2 and 3, if we were going to show how this would work, this is saying 4 to the second power. So that means 4 times itself 2 times. And that's what this represents. We have the multiply times. And then 4 to the third power, that means 4 times itself 3 times. That's what since there's 3 factors of 4 here. So we have a total of 1, 2, 3, 4, 5 factors of 4. So our answer would be 4 to the 5th power. So if we know 7 to the 5th power times 7 to the 6th power, we have the same base. We're just going to add our exponents. 5 plus 6 is 11, so our answer would be 7 to the 11th power. So now let's try these on your own. Try using these, using a single exponent. So pause the video, solve these 3 problems. All right, let's go over these following our rule by looking. As long as our bases are the same, we're just going to add our exponents. In this case, we're dealing with a negative number, so when we have opposite signs, we're going to subtract and keep the sign of the larger number. So in this case, it's going to be 8 minus 3 is 5. Positive 5 because 8 is bigger than 3, and 8 is positive. This one, we have negative 4 plus negative 3. We're going to add both integers together, being that they have the same sign. 4 plus 3 is 7, and we're going to keep the sign, negative 7. So our answer is going to be 2 to the negative 7th. Our last example is the fraction 5/6 to the 4th power times 5/6 to the 5th power. Same base, which is 5/6, that's okay. We're going to add our exponents. 4 plus 5 is 9, so our answer is 5/6 to the 9th power. Notice we keep those in parentheses. Next rule, dividing numbers with powers. So when we do that, we have to subtract our exponents. We keep the base, and we subtract our exponents. So to show how this would work, if we add 3 to the 5th power over 3 to the 2nd power, and we did this we wrote it out as an expanded form. So 3 to the 5th power means 3 times itself 5 times. 1, 2, 3, 4, 5. The denominator in this fraction would be 3 to the 2nd power. That means 3 times itself 2 times. 3 times 3. So if we were going to pair up our numerator with our denominator of matches, so 3 and 3. So we have 2 groups that match together. That's what this represents. And then we still have a remainder of 1, 2, 3. And since these essentially cancel out, there's a 1 underneath. So we have 3 times 3 times 3, and then a 1. So we're going to simplify all this. 3 over 3 times 3 over 3 times 3 would become 1. Then we still have 1, 2, 3, 3, so we write that as 3 to the 3rd power. And to simplify it further, 1 times 3 to the 3rd is 3 to the 3rd. So if we know 3 to the 5th power over 3 to the 28th power, we're going to subtract our exponents to get 3 to the negative 23rd. 5 minus 28 is 3 to the negative 23rd. So now we try these. You remember when we're subtracting these, we can say keep, change, opposite, or keep, change, flip. So we keep the 5, change our sign to plus, and make our 28 negative. So it'd be 5 plus negative 28, which then we get opposite signs, we subtract them. 28 minus 5 is 23. 28 would have been negative. 28 is bigger than 5, so our answer is going to be negative. Negative 23. Now let's try these on your own. Pause the video. All right, let's go over these. So if we look at to make sure our bases are the same, and we're going to subtract our exponents. So in this case, it's negative 5 minus 4. So we would subtract these. So negative 5 minus 4. So we keep. We change the sign to plus, make this negative. Negative 5 minus or plus negative 4 would be negative 9. Second one, we're going to keep our base 6, and we're going to subtract our bases, so it's going to be 5 minus a negative 8. So I'm going to change it to plus, and make this its opposite, so it becomes plus, so it's going to be 5 plus 8 is 6 to the 13th power. And our last example, we're going to keep our base the same, it's 10, it's negative 12 minus 20, so I'm going to keep negative 12, change our sign from minus to plus, and make 20 its opposite to be negative 20. So it's negative 20 plus, I'm sorry, negative 12 plus negative 20, which would be negative 32. 10 to the negative 32nd. If we had this rule, a power to a power, that means we're just going to keep our base, but we're going to multiply our exponents. N times M. So how does this work? We had 8 to the second power all raised to the third power. So what that means, we're going to have 3 groups of 2 factors of 8, because it tells us 8 to the second power is 2 factors. We need 3 groups of that, because our outside exponent tells us how many groups we need. So 8 times 8 is the first group, 8 times 8 is the second group, and 8 times 8 is the third group. How many factors of 8 do we have? 1, 2, 3, 4, 5, 6. So our answer is going to be 8 to the 6th power, or 6 factors that are 8. So if we know 7 to the second power all raised to the third power, we'd multiply our exponents and keep our base. So it's going to be 7 to the 6th power. Now try these on your own, right, using a single exponent. So pause the video. All right, let's go over these. So we're going to keep the base and multiply our exponents. 4 to the third power all raised to the negative third. So we're going to multiply 3 times negative 3, be negative 9. We have unlike signs, so our exponents can be negative. So I would say 4 to the negative 9th power. This one, 2 to the negative 8th, all raised to the negative 4th. So we're going to multiply our 2 exponents and keep our base. So it's going to be 2. Negative 8 times negative 4. Negative times a negative is going to be a positive. So it's going to be positive 32. So 2 to the positive 32nd. And our last one, 6. We'll keep our base. We're going to multiply our exponents. Negative 3 times 5. They're opposites, so our answer is going to be negative. So 3 times 5 is 15. So our answer is going to be 6 to the negative 15th power. Next rule, a base to the 0 power, any number to the 0 power will equal 1. So how would this look? Show how it works. If we had negative, if we know 7 to the 5th power times 1 is 7 to the 5th power, but if we multiply that times 7 to the 0 power, that means we're going to add our exponents. 5 plus 0 is 5. So 5 plus 0 is 5, so that would be 7 to the 5th power. So that's telling us, if we know that 7 to the 5th power times 1 is 7 to the 5th power, but also when we figure this out as we use 7 to the 0 power, it has to equal 1. So we just proved it, this method. If we had the division method, we're going to subtract our exponents. 6. So if we wrote 7 to the 6th power over 7 to the 0 power, we're going to subtract our exponents. 7 to the 6th power. We're going to subtract 6 minus 0, which is still 7 to the 6th power. So it has to equal 1. So any number to the 0 power is going to equal 1. So 5 to the 0 power equals 1. So now try these on your own and write using a single exponent. Pause the video. All right, let's go over our answers. So be careful when you're looking at these with what operation you're doing. This is a division problem. So when we are dividing, we have to subtract our exponents. So we'll keep our base, but subtract our exponents. 5 minus 5 is 0. So 10 to the 0 power, which is equal to 1. 3 to the 4th power, all raised to the 0 power. We're going to multiply our exponents and keep our base. So it's going to be 3 to the 4 times 0 is 0. 3 to the 0 power, which is equal to 1. And our last one, we're multiplying, so we have to add our exponents, keep our base. 8 plus negative 8, they're opposites, it's 0, so 2 to the 0 power, which equals 1. Next rule, we have a base to the negative exponent, and we want to make that positive. Essentially, we're going to take a reciprocal. That means we're flipping it. So any whole number has a 1 underneath it. So to make our exponent positive, which you're going to be asked probably quite frequently, is to keep our answers with positive exponents instead of negative exponents. So essentially what we're going to do is flip it. So our x to the n power will go to the bottom of our fraction, which is our denominator. And when we do that, it becomes positive. And the 1 underneath that we assume here is now going to go to the top, our numerator. So it's going to be 1 over the base to the nth power. So how does this work with numbers? If we had 9 to the negative 3rd power, we're going to make that into a fraction. We have to do it 3 times. We want to make it into a positive exponent. So think of this as 9 over 1. So I'm going to flip it. So it's now 1 over 9. And I have to do that 3 times. 1/9 times 1/9 times 1/9. So 1 times 1 times 1 is 1. 9 times 9 times 9, and we want to keep it in an exponent form. So 9 to the 3rd power, because it's 1, 2, 3. So 2 to the negative 7th equals 1 over 2 to the positive 7th. Because all we're doing is we always assume there's a 1 underneath here. We're going to flip it. So the 1's going on top, the numerator. The 2 to the negative 7 now goes to the bottom, but when we bring it down to the bottom, our exponent now becomes positive. So now try these on your own, right, using a single positive exponent. So if you come out to be an answer to be a negative exponent, make it positive by doing the reciprocal, by flipping it. So pause the video, try these 3 problems. Our first example, 3 to the negative 23rd power. So we assume there's a 1 underneath here, so we're just going to flip it. It'll be 1 over 3 to the 23rd. Notice when we bring it down to the denominator, our exponent becomes positive. 11 to the negative 8th should tell us we want to flip it, and it becomes 1 over 11 to the positive 8. In our last one, 4 to the negative 9th, we are going to flip it, so it becomes 1 over 4 to the positive 9th. So how do we actually evaluate 2/3 to the 3rd power? So think of this as we need to multiply 2/3 times 2/3 times 2/3, because 2/3 is our base, and we need to do that 3 times. So if we were doing this, how many 2's do we have? 1, 2, 3. 2 to the 3rd power, that's our numerator. And our denominator, our bottom number, we have it 1, 2, 3. So 3 to the 3rd power. So think of this as almost kind of like the distributive property, where we are going to cube or go to the third power for both the numerator and our denominator. So we need to go a little bit further. 2 to the third power, that means 2 times itself 3 times. So 2 times 2 is 4, times 2 again would be 8. And 3 times 3 is 9, times 3 again is 27. So our final answer, when we're asked to evaluate, is 8 over 27. All right, looking at these, are these the same or different? So we have -4 in parentheses squared versus -4 squared, or to the second power. Are they going to be the same or different? I hope you said they're different. So let's prove why. So if we're looking at our first example of in parentheses negative, so we could say the quantity of -4 squared. If we broke that down, that means we are taking what's inside our parentheses and we are going to be squaring it, or to the second power. So -4 times itself 2 times. -4 times -4, which comes out to be positive 16. Because a negative times a negative will become positive. 4 times 4 is 16. Now let's take a look at this one. -4 to the second power. But notice we don't have a parentheses in this one. So it's going to be a little bit different. So our negative is going to hang out on the far side. But this exponent is just referring to the 4. So it's going to be 4 times 4. Well, we know that 4 times 4 is 16, but this negative is still going to be there, hanging out. So our answers actually come out to be -16. So they're opposites. So when you're looking at problems like this, you have to be very careful by looking at, are we referring to the quantity of -4, that means in parentheses, or is the parentheses taken out? So essentially, when we're looking at this -4, we would, inside parentheses, we're multiplying the number times itself inside that parentheses, so everything inside. In this one, they're only referring to 4 to the second power. You're going to be referring this, but we got to keep that negative present. All right, so true or false is 1/3 to the second power times 1/3 to the fourth power equal to 1/3 to the sixth power. True or false? I hope you said true. Because we have the same base of 1/3, so we're just going to add our exponents. 2 plus 4 is 6. So 1/3 to the sixth power. Let's try another one. If we have 3 to the second power times 5 to the third power equals 15 to the fifth power. So is that true or false? I hope you said false. There's a couple of reasons. They do not have the same base, so they don't have exactly, so they're one's a 3, one's a 5. They would have to be exactly the same. So you can't add the exponents. Or you can't multiply the exponents either. Let's take a look at this one. True or false? We have 5 to the fourth plus 5 to the fifth equals 5 to the ninth power. Is that true or false? I hope you said false, because 5 to the fourth and 5 to the fifth are not being multiplied. So we don't add the exponents. So this would have to be a multiplication problem for us to add the 4 and the 5. All right, so just a review of what learning targets we went through today. I can change an expression with a negative exponent into an equivalent expression with a positive exponent. In our second learning target, I can choose an appropriate exponent rules to rewrite an expression to have a single exponent. So, if you have any questions, make sure you email your teacher. So today, that's it for today. So we want you to head on over to Schoology and complete today's assignment. Have a good day.